Okay, so I've had some questions about, in part 2 of experiment 15, how to figure out the equivalent mass of an unknown acid. And then in part 3, how to figure out how many grams of your unknown acid is going to be titrated with 20 milliliters of titrant. And so we know that our equivalent mass is grams of acid per 1 mole of H+. Right, so if I wanted to add a very specific number of moles to my solution, I could measure out however many grams of acid I need to get that number of moles. And so let's start off by figuring out what we have and what we need to calculate. So you know the grams of acid, right, because you calculated it, you measured that in the lab. Next we need to figure out how do we get to the moles of H+ that we added. So the first thing I know that I have is my volume of NaOH here. So if I have my volume of NaOH, I know that this OH here reacts in a 1-to-1 ratio with my H+, but it's in milliliters. So all I need to do is go from milliliters to moles of NaOH. And then 2, I know that my moles of NaOH are going to equal the moles of OH minus, because as it dissolves, it just every single mole of NaOH breaks down and gives off 1 mole of OH. 3, I know that my moles of OH is going to equal moles of H+, because they react in a 1-to-1 ratio. And then, boom, I have my moles of OH+. I just plug it in here to my equivalent mass equation, and I can calculate equivalent mass. So in part 3, when we need to figure out how many grams of an unknown acid to add in order to be titrated by 20 milliliters of NaOH, well, I know by using the same process I can figure out this H+ right here. I also know if I'm using the same unknown acid, I know what the equivalent mass of that acid is. So now I have every single piece of the puzzle except the grams of acid that I actually need. So all I would need to do for part 3 is solve for the moles of H+ that will be neutralized by 20 milliliters of NaOH. So 20 milliliters, I go through this process, figure out moles of H+, and then rearrange and solve for grams of acid.